In this video, I'll show you how to solve a word problem involving trigonometric models. This is question 2. The question reads, a Cepheid variable star is a star whose brightness alternately increases and decreases. Suppose that the interval between times of maximum brightness for a particular star is 7.3 days, its average brightness is 5.0, and that it changes by plus or minus 0.2. A. Formulate a model for the form y is equal to a times sine bx plus d, and B. If the brightness today is 5.0, how long will it take until the star reaches its maximum brightness? To help us tackle question A, I've reintroduced information about the general sine function, as shown below. And according to the question, it tells us that suppose the interval between times of maximum brightness for a particular star is 7.3 days. What this is telling us is the period, meaning that everything occurs within that 7.3 days. So what we can do is use this formula right here, period is equal to 2 pi over b, and substitute period with 7.3. By doing that, we can now isolate for b. We isolate for b by multiplying both sides by b, and then subsequently dividing both sides by 7.3. So if I do this first step, that cancels out, and we have b is equal to 2 pi over 7.3. So technically, we have found this part. The next thing that you should find is d. If you recall, d is the number that will influence the vertical shift to go up or down. And the way you find d is you take the maximum and minimum values and you divide by 2. You find the average between the max and minimum of the wave function. So let's write that down. D is equal to the maximum minus the minimum divided by 2. Now if you read the question again, it says its average brightness right here is 5.0. This formula right here is the average. If you take two numbers and you want to find what's in the middle, you take the first number and the second number, subtract them and divide by 2. So technically our D is the average, and the average happens to be 5.0. Next, we will find our A value. And our A value, if you recall, is the amplitude. Now what is amplitude? To help us understand, let's take a look at a sine function. A sine function, y is equal to sine x, would look like this, where it starts at 0, makes its way to 1, and then back. And the amplitude of a sine function is 1. Also, the d value for a sine function is 0. So let's reread the question. And it says, that last part, and that it changes by 0.2, plus or minus. So the average changes by plus or minus 0.2. So if we define the amplitude as the distance from the center to the maximum or minimum, and if the average for our particular case was 5, and it hovers between negative 0.2 and 0.2 positive, that means that our amplitude for this problem has to be 0.2. So that being said, we can now put this all together. Y is equal to 0.2 sine, and our b value was 2 pi over 7.3 x plus 5. Let's move on to part 2. In part 2, they're asking if the brightness today is 5.0, how long will it take until the star reaches its maximum brightness? To answer this question, you have to recall what a sine function looks like. And remember, a sine reaches its maximum when you have pi over 2. And at pi over 2, you have y is equal to 1. That's when it reaches its maximum. And the same will happen for the equation that we found. Recall, this was the equation that we found in part A. And so, sine at pi over 2 will give us the maximum. Therefore, we need to find the equivalent of this part to pi over 2. And the way we would do that is we would take the insides here, 2 pi over 7.3x, and you'll make this equal to pi over 2. Essentially, what we're doing is we're finding a factor that will enable us to get to pi over 2. And all we do from here is solve for x. So I'll multiply both sides by 7.3, 7.3 pi over 2, and by multiplying this left side by 7.3, it cancels out. And on the left side, you're left with 2 pi x. Next, I'm going to divide both sides by 2 pi. So x is equal to 7.3 pi over 2 divided by 2 pi. And this resolves to 7.3 over 4 is equal to 1.8. 1.8 what? How long will it take? It will take 1.8 days for the star to reach its maximum brightness. And that's it. That is how to solve this word problem involving trigonometric models. If helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.